Hi there, folks. Today we're looking at congruent figures, okay? And so when we talk about the idea of congruence is when things are the same, but we're talking about a shape, all right? We've talked about congruent angles and congruent segments and that kind of thing. So this is when the shapes are the same. So now we're going to kind of expand that out into congruent polygons. So congruent polygons, all their corresponding parts are congruent as well. And that's the big thing that happens here. So we already know the concept of congruent. So congruent polygons, well, the shapes are identical in every way, which means the corresponding pieces are congruent, all right? For example, if I look at this particular group here, these are congruent polygons, and I know that they're congruent because all of their pieces match up. If all the pieces are congruent, then the entire polygons are congruent, all right? If we had one of these sides that didn't match up, well, then these wouldn't be congruent polygons, okay? All the angles match, so we have a pair of angles, and when we start to match these things up, we can see that A is congruent to W, all right, in terms of the angle, all right? Angle D is congruent to angle Z. Angle C is congruent to angle Y. Angle B is congruent to angle X, all right? We can compare the sides, and we can match each side of one polygon up with one side of the other polygon. These are congruent polygons. And when we label these things, we have to label them in a specific order. So for this one, if I said, polygon ABCD, when I list the other polygon being congruent to this, I have to match up the pieces. So like we just talked about angle A was congruent to angle W. So in terms of labeling, the first one started with A, the second one has to start with W, okay? Likewise, we can see that angle B matches up with angle X, so that has to be listed next over here, okay? C matches up with Y. D matches up with Z, okay? This would be an appropriate name for these polygons. I couldn't say something like this. If I said A, B, C, D, I couldn't just call this other guy X, Y, Z, W, okay? I can't just label them at random. When I look at the names of these things being congruent, it should show me the corresponding parts. And so when you look at this thing, you can see that A is in the same position as W. Well, those are the angles that match up. Even the segments, when we look at the lines, like right here, segment AB compared to segment WX. And when you look back up here, well, yeah, those two pieces are congruent. They're congruent segments within this thing. So the name should show us the congruent pieces as well. All right. For example, if I look at something like this guy, even without having a picture, without having a drawing, when we looked at the other picture, that was really easy to say, oh, this segment's congruent to this segment. But now, without even having the picture, let's name all the corresponding parts. So if I have two polygons that are congruent and they're labeled above, just by the name, I can tell you that angle H is congruent to angle L. Likewise, I could say that angle I is congruent to angle M. Angle J is congruent to angle N. And angle K is congruent to angle O. Okay? And I can say that because the naming puts these things in the same order. It shows them in corresponding order. Likewise, I can do the same thing with the segments that we're talking about here. If I kind of jump to the segments, I could say that segment HI is congruent to segment LM. And again, it's right out of the name. Segment IJ is congruent to segment MN. Segment NO is congruent to JK. Sorry, I did that one in reverse order, but that's okay. And then the one that students tend to struggle with is the kind of this wraparound one. Notice like HK or KH. Well, match up the same thing over here would be OL. Okay, so keep that in mind. The naming shows us the congruent pieces, or should show us the congruent pieces. Okay. If we look at something like this guy, it says the triangle ABC is congruent to triangle DEF, and I want to find the measure of angle D. All right. So once again, because I'm looking at this thing and I can see in this diagram, I've got angle B and I've got angle C labeled. which means I know angle A matches angle D. I know that angle B matches angle E. So I can kind of transfer these over to the other triangle. So like in this one, A and D are the same thing, which means this guy matches this guy. Likewise, I could see that B and E are the same thing. So this guy matches this guy, so I can transfer that 30-degree angle. And likewise, with the last piece of this thing, C and F, those match up, so I can transfer the 65-degree angle. And so there's two ways to kind of approach this. I can either look at it the way that I've done it here, where I've kind of moved those guys over, and then I can say, hey, the three angles inside here have to add up to 180. Or I could find angle A to start, say, hey, the three angles in here have to add up to 180 degrees. Right now I have 95 degrees, so I need another 85. So this is 85 degrees. And then I can say, hey, D matches that, so angle D is 85 degrees. Or I could transfer the two angles I have and then look at this second triangle and say, hey, this has got to be 85 degrees. Okay? So it doesn't matter which way you do it, but you'll get the same result. So right here, angle D, measure of angle D equals 85 degrees. Okay? But again, it's because these parts match up. If I look at this guy, it's saying, all right, name the congruent triangles, if any, and we have to justify our answer. And with triangles, we'll kind of find some better ways to determine if triangles are congruent. For now, we're going to treat it like polygons, which means I just have to make sure all the different parts match up. Okay? And if all the different parts match up, then I can say that the polygons are congruent. All right? With triangles, we'll find later that we don't need quite as much information as other polygons. Okay? But I just start looking at this thing and I say, okay, well, looks like angle A and angle E match up based on what I see here. So those two angles match up. Angles B and D match up because they're both 90 degrees, so these angles match up. So then if I look at this last set of angles, okay, looking at these guys right in here, I want to see this angle and this angle have to match up. And so I have to ask myself, do those angles match? And the answer is yes. I can say that those angles match, that this angle is congruent to this angle because those are vertical angles, okay? So that's my first piece of this justification. And then the last thing I would have to do is I'd have to match up all the sides at this point. So let's match up the sides. I can see that here's a 10 and here's a 10. So AC and CE match up. If I look at these other guys, CD and BC, those match up. So I just have to match up that last set of sides. And if we kind of think about this for a moment, these are right triangles. If you remember your Pythagorean theorem, you could do a squared plus b squared equals c squared. You could solve for AB over here, and you'd end up with an 8. Same thing in the other triangle, because it's a right triangle, a squared plus b squared equals c squared. You could solve for DE and end up with an 8. And so I can see that those last set of sides also match up. Okay? So what I've done here is I've shown that every part of one polygon matches every part of the other polygon. That is a justification for saying that these things are congruent. Okay? So triangle ABC is congruent to, and once again, be careful with the naming here. A matches E, all right? B matches D, and C matches itself, okay? So triangle ABC is congruent to triangle EDC, okay? And again, I can justify that. I justified the angles at C being congruent because of vertical angles. I justified those sides being congruent because I was able to find those values. And now I can say that these two triangles are congruent, the two polygons are congruent because all the parts match, okay? And once again, with triangles, we don't actually need that much information. We can do it with a lot less, and that's something we'll do in the next couple lessons. If I look at something like this guy, the third angle theorem, and so we're just going to do a two-column proof here, and really this deals specifically with triangles. If I have two angles for a set of triangles that are congruent, that match up, I can immediately say that the third angles also have to be congruent. Okay, that's what we're trying to prove here, all right? So here it's telling me that A is congruent to D, and one of the things I'll always do is I'll label the picture, so A is congruent to D. Also, B is congruent to E. And the thing I want to prove is that C is congruent to F. Okay, I've got two pairs of these angles that are already congruent. I want to show that the third set are also congruent. So I'm going to do a two-column proof here, statements and reasons. And I'm going to start with my given like I always do. Okay, so these are congruent, and that was given to me. And so now I just kind of have to start thinking about what I know in terms of each of these triangles. And one of the things I know is that, well, the three angles inside a triangle add up to 180 degrees. Okay, so right here I could say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And I could do the same thing for the other triangle as well. And again, the justification there, I can just say that I know the angles inside a triangle add up to 180 degrees. That's a theorem that we proved earlier. So angles in a triangle add to 180. Okay, and then from here, what we really want to do is we want to start kind of replacing some of these pieces, but I can't do that just yet. Okay, when we start thinking about the fact that I have like angle A is congruent to angle D and angle B is congruent to angle E, I'm going to need another step in there. We could do this. We could say at this point, that the measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle D. Sorry, I had to spill over onto the other line here. And I can say that because they were each equal to 180. We could kind of think of that in terms of our transitive property. The measure of A, B, and C is 180. 180 is D, E, and F. So now I could say that A, B, and C equal the D, E, F kind of thing. So that's my transitive property. But then from here, I want to be able to kind of start moving some things around. And if you look at that first step, the thing that's given, if we just kind of translate that into equal signs instead, so the measure of angle A is equal to the measure of angle D, and the measure of angle B is equal to the measure of angle E. So the same thing that was listed in the given, but remember, congruent means that they're equal. I can't really start subtracting things from each side until I have these in terms of the measurements. It's one of those really silly kind of steps that students tend to forget all the time. But that's just the definition of things being congruent. Okay? Things are congruent, their measurements the same. Now, if I look at that equation from step 3, couldn't I subtract the A/D from each side? Since they're equivalent, can I subtract the same thing from each side and kind of get rid of the A and the D on each side? Couldn't I take away the B and the E on each side? And so if I kind of look at that step 3, if I were to take away the A and the D from each side, subtract those from each side, and then take away the B and the E from each side, maybe it would help if I kind of cross these out, like take those guys off of each side, subtract them from each side, and then take these guys off of each side, subtract them from each side. The thing I'm left with is that the measure of angle C equals the measure of angle F. And see, the justification there, when I look at the step that I wrote right before this in step 4, is because A and D are the same thing and B and F are the same, or B and E are the same thing, I'm taking away the same thing from each side. I'm using my subtraction property of equality. Okay. Some teachers might have you substitute in here first and replace like A with D and then replace B with E, that kind of thing, so that you're literally subtracting the same thing from each side. But in step 4, we're saying they're the same thing. So to me, that's a reasonable justification. You could include another step in there with substitution. But now from here, if those two things have the same measurement, we can now say that they're congruent. And once again, that's what congruent means. It means that the two shapes have the same measurement. So if they're the same measurement, I can say they're congruent. Once again, I'm just going to say that's the definition of things being congruent. Okay? And so this might have seemed obvious from the start because of the idea of these things equaling 180. But here's our proof. Okay? If we have two angles that match up in two separate triangles, then guess what? The third angle has to match up also. Okay? So if two angles of one triangle are congruent to two angles from another triangle, then the third angles are congruent. Okay? So now if we look at this one, again, we're just going to do a proof here. Maybe we'll use some of the stuff that we've learned. It'll be great. So we're starting with this, and I'm going to label the picture. All right? I always like to label the picture. It makes things really easy as I go through the given. So angle B is congruent to angle D, so these guys are congruent, so I'm going to label it on the picture. Angle CAB, which is this guy right here, is congruent to angle CAD, this guy down here. Segment AB is congruent to segment AD, so I'm going to label each of those. Segment DC is congruent to segment BC, so I'm going to label those. And now I want to prove that the two triangles are congruent, all right? So again, if I think about what we've done so far, just thinking about congruent polygons, we just have to show that all the parts are congruent, okay? And that's part of the definition of congruent polygons. So here we go, statements and reasons. I'm going to start with what I know, and I'm just going to list all of it, even though I might not use all of it right away. I'm going to list it all. All right, and that's my given. So now think about what I have so far. Right now I have almost everything. I just need to show one more set of angles and one more pair of sides congruent in order to have all the pieces here. And so I just start looking at this thing and saying, okay, do I know that angle ACB and angle ACD are congruent? And if I do, how do I know? And hopefully you're looking at that going, you know what? They are congruent. And that's the theorem we just used. Okay? So angle ACB is congruent to angle ACD. And I know that because of that third angle congruent theorem, the one we just proved. And really, you don't have to memorize the name. You just have to state what this thing says. An if-then statement is good if two angles of triangles are congruent. Then the third angle are congruent. Okay, that's the one we just went through proving. If two of the angles from one triangle are congruent to two angles from another triangle, then guess what? The third pair of angles are also going to be congruent. Okay, they're also the same. Okay, so now let me add that to the picture. I have that these guys are congruent. The only thing I have left is that last side, which is the same side for each triangle. Like when you look at the triangle on the top, AC is the side that I don't know about. And when you look at the triangle at the bottom, AC is the side that I don't know about. Well, I can say that those two things are congruent. Just say that segment AC is congruent to segment AC. It's congruent to itself. It's this guy right here. And the reason for that one, that's my reflexive property. And that's one of those properties that you probably were introduced to in algebra, but you thought, oh, we're never going to use that. This is where we kind of use that. All right. When we're talking about these shapes and using that reflexive property, it's when they share these pieces, but we're talking about two separate shapes. Okay. So now by saying that, I've just shown that every piece from one triangle is congruent to every piece from the other triangle. So I can say that the two triangles, triangle ABC, is congruent to triangle ADC. All right? And that's part of the definition of congruent polygons. Okay? If all the pieces are the same, then the polygons are the same. If all the pieces are congruent, then the polygons are congruent. Okay?